All right, welcome back everybody. This is Noah, and in this video we're going to be looking at finding x-intercepts via completing the square when the leading coefficient is not 1. All right, so the instructions are pretty much just the title of this video: find the x-intercepts of the following functions by completing the square. What we'll notice with all the functions that were given here, the leading coefficient in front of the x squared is not a 1. So let's take a look at how we can address this. What we're going to do, we're looking for the x-intercept, so we'll start by setting the equation equal to 0, set the output to 0. 0 equals 2x squared minus 4x minus 6. And we could do this a couple of different ways, but I want to focus on a factoring out from the first two terms, because this is going to be helpful as we move into the next section where we have to do the same thing. So before I do that, we're going to just add this 6 to both sides to kind of get it out of the way so we can focus in on those first two terms, the 2x squared minus 4x. So when I do this, I'll have 6 equals 2x squared minus 4x. And what we want to do is we want to move the 2 off of the x squared. So to do that, I'm going to factor a 2 out of both of these terms. So I have 2 times x squared minus 2x. And then we're going to complete the square for what's inside these parentheses here. So before I do that, I'm going to just go ahead and divide the 2 out of both sides, so it's also out of the way. So we get 3 equals x squared minus 2x. And now I can go ahead and say 3 equals parentheses x minus 1 quantity squared. Sorry, I need that extra line in here. 3 equals x minus 1 quantity squared, but if we FOILed this out, it would give us a plus 1 that we've just added to this side, right? If I FOILed out the minus 1, it would give us a plus 1 right here. So we need to show that we've added 1 to this side and then add 1 to the other side as well, which turns that 3 into a 4. Now we can take the square root of both sides, remembering to put a plus or minus when we take the square root. So we end up with plus or minus 2 equals x minus 1. Let me go ahead and move up to the right here. So I've got plus or minus 2 equals x minus 1. I'm going to break this into 2 separate equations. I have 2 equals x minus 1, or negative 2 equals x minus 1. I go ahead and add 1 to both sides of the first equation to get x equals 3, or 3 equals x. I guess I'll keep it in the same order here. Add 1 to the second equation on both sides, and we get negative 1 equals x. And so we can say that the x-intercepts are 3, 0, and negative 1, 0. Move this over a bit. That's not very long room here. All right, let's take a look at another one. Here we've got g of x equals negative 2x squared minus 16x minus 14. And we want to find the x-intercept, so we'll set the output to 0. 0 equals negative 2x squared minus 16x minus 14. We'll start by moving the 14 over to the other side. So we'll add 14 to both sides to clear that out. So I have now 14 equals negative 2x squared minus 16x. And to complete the square, we want to factor that negative 2 out first. So I'll say, oops, 14 equals negative 2 times x squared. Now when I factor a negative out, that middle minus becomes a plus. Be really careful with that. Easy thing to miss. X squared plus 8x now. And now our goal is to complete the square of that. So I could divide the negative 2 here. Let's get that out of the way just to make our lives a little easier. Divide by negative 2 on both sides. And we'll get a negative 7 equals x squared plus 8x. So I'm going to go ahead and skip a line. I want to have x plus half of 8 is 4 right here. So this is always going to be half of that number. And then when I square that out, we've now added a 16 to this side. Right? This is x plus 4 squared would FOIL to x squared plus 8x plus 16. So we need to add 16 to both sides, giving us 16 minus 7 is a 9. Now we can take the square root of both sides to cancel out the square. And we'll get a plus or minus 3 equals x plus 4. So we can break this into two equations. X plus 4 equals 3, or x plus 4 equals negative 3. Subtract 4 from both sides of both equations. And we will get x equals negative 1, or x equals negative 7. So our x-intercepts are negative 1, 0, and negative 7, 0. All right, so these are going to get progressively more difficult now as we begin to move forward. So make sure and pause the video as you need to. Make sure you're understanding all the steps that I've got here. We have h of x equals 3x squared minus 18x minus 10. So I set the output to 0 to find the x-intercepts. 0 equals 3x squared minus 18x minus 10. We're going to add 10 to both sides to get that out of the way. So we've got 10 equals 3x squared minus 18x. And then we want to factor that 3 out from in front of the x squared. So we'll have 10 equals 3 parentheses x squared minus 6x. 3 goes into 18 6 times. And then we can go ahead and divide the 3 off of both sides here. And now we see why this gets a little bit more difficult. We've now got a fraction on the left side. I've got 10 thirds equals x squared minus 6x. So I'm just going to let the 10 thirds be what it is. It's going to be a little bit more of a pain to deal with. It's just going to add some tediousness to the problem, but we want to use our fraction arithmetic and make sure that we can get through this still. So in order to complete the square, I'll say x minus 3. That's always half of that b value from the previous line. So I have x squared minus 6x. So I take half of the minus 6 is a minus 3, and we do x minus 3 squared. Now if I were to FOIL this out, I would get a plus 9 that I've just added to both sides in order to do so. So that's actually going to change that 10 thirds, right? If I come over here and say, what's 10 thirds plus 9? It's a 9 over 1. We want to keep this as an improper fraction for now. This is going to be 10 thirds plus 27 thirds by getting a common denominator, times 3 top and bottom there on that 9 over 1. And so we will get 37 over 3. All right, so now we can take the square root of both sides, but in this case, it's not going to be such a pretty number. So take that square root of both sides using a plus or minus when I do so. And we get plus or minus the square root of 37 over 3 equals x minus 3. I'll add 3 to both sides to isolate the x. So we have 3 plus or minus the square root of 37 over 3 equals x. So our x-intercepts are the points 3 plus the square root of 37 over 3, 0, and 3 minus the square root of 37 over 3, 0. One other thing that we could do with this is if I look at the number square root of 37 over 3, we could multiply the top and the bottom by the square root of 3. And this is going to give us, on top we'll have the square root of 90, and 21 is 111 over, and then on the bottom we'll just have a 3. So we could replace that square root of 37 over 3 with the square root of 111 over 3, so that we've rationalized the denominator. Some teachers are more picky about doing that than others. I think the most important thing is that you can do it if you want to. So know that you could do that if you wanted to. I personally am okay with that non-rationalized form, but be okay with the fact that those are the same thing. All right, let's keep going here. We've got some more, and we're just going to see fractions get involved a little bit more heavily. I think this one's not going to be any more difficult than the last one, but we'll start to see more fractions as we move forward here. So j of x equals negative 2x squared minus 8x plus 12. Set the output to 0. 0 equals negative 2x squared minus 8x plus 12. And subtract the 12 off of both sides to get negative 12 equals negative 2x squared minus 8x. We'll then factor a negative 2 off the right side, so negative 2 times parentheses x squared. That'll change the sign to a plus 4x in here. Then we can divide the negative 2 off of both sides to get 6 equals x squared plus 4x. All right, so we want to complete the square here. I'll leave myself a little bit of room. Say something equals parentheses x plus 2, the plus 2 being half of that plus 4 there. But we want to square this. When we do that, if we FOIL this, we'll get a plus 4 at the end, so I need to add that to both sides. So we end up with 10 equals x plus 2 quantity squared. Now we can go ahead and take the square root of both sides, not forgetting the plus or minus square root when we do so. So we end up with plus or minus the square root of 10 equals x plus 2. We can then subtract 2 from both sides to get negative 2 plus or minus the square root of 10 equals x. And then we break this up into 2 separate values. So x equals negative 2 plus the square root of 10, or x equals negative 2 minus the square root of 10. So that was nice. There actually wasn't any fractions in that, but we still have this square root that we can't simplify. That square root of 10 doesn't really have anything happen with it to make it get any simpler than that. So we can say that the x-intercepts are the points -2 plus the square root of 10, comma 0, and -2 minus the square root of 10, comma 0. And as always, we could always plug these numbers into a calculator and find out what they're done. And get those. There's nothing wrong with just leaving those as an exact value unless we have a reason to plug it in to the calculator. All right, we've got 2 more examples here, and we'll see some more fractions crop up now, I believe. For this one, we have the function k of x equals 2x squared minus 2x minus 5. We set the output to 0, so 0 equals 2x squared minus 2x minus 5. Go ahead and add the 5 to both sides to get it out of the way. So we end up with 5 equals 2x squared minus 2x. Then we factor the 2 off of the front, off the x squared there, so we get 2 parentheses x squared minus x inside. And then we can divide the 2 off of both sides. All right, so on the left side we'll have 5 halves equals, on the right side just x squared minus x. All right, so we want to complete the square. I'll skip a line and get to the answer x minus, now this is a little interesting. This is the previous line says x squared minus x. That's a minus 1x. So half of that is 1/2. So our completed square is going to be x minus 1/2 squared. And if I do that, when I square 1/2, we're adding, it becomes a positive 1/4 when we square it. So we've now added 1/4 to both sides by doing this process. All right, so I need to know what is 5 halves plus 1/4 in order to simplify the left side. If I multiply top and bottom by 2 for that 5 halves, I can get my common denominator of 10 over 4. And we've got plus 1/4, so that's going to equal 11/4. So we've got 11 over 4 equals x minus 1/2 quantity squared. All right, let's go ahead and take the square root of both sides now. Plus or minus when we do so. And when we do this, this actually simplifies nicely. We'll have a plus or minus square root of 11 over 2, because we can take the square root of 4 and have a 2 in that denominator. On the right side, we now just have x minus 1/2. We'll go ahead and add that 1/2 to both sides. And we will get 1/2 plus or minus the square root of 11 over 2 equals x. So from this we can get our x-intercepts as the point 1/2 plus the square root of 11 over 2, comma 0, and 1/2 minus the square root of 11 over 2, comma 0. All right, so fractions all over the place. Don't be afraid of them. I know that they are and go over and make sure you've got your fraction arithmetic worked out and continue forward with the problem. Last one for this video, we have L of x equals 3x squared plus 5x minus 2. We set the output to 0. 0 equals 3x squared plus 5x minus 2. I'll add the 2 to both sides, get it out of the way. So we have 2 equals 3x squared plus 5x. Now we want to factor that 3 off that x squared, but now we're running into something a little bit more complicated here because 3 doesn't go into the 5. So what we do is this little thing called force factoring. A GCF, a greatest common factor. And that's not, it's not a whole number greatest common factor. We're just force factoring something out of this. So I'll have 2 equals 3 is what I'm trying to pull out, parentheses x squared, plus, when I force factor this, I'm going to have a 5/3, so that when the 3 multiplies back in, we would get back to the 5. Remember, factoring is essentially a division process. So it's 5/3 when we do that. Okay, so then I can divide the 3 off the front here to get 2/3 equals x squared plus 5/3 x. And then to complete the square, I'll skip a line and say we want x plus half of 5/3. So 5/3 times 1/2 is 5/6. So we want x plus 5/6, quantity squared. But that adds, that then causes us to have added 25/36 to this side. So we need to do the same to the left to keep this all in balance. Add 25/36. So I need to do 2/3 plus 25/36 off to the side. To get a common denominator, I'll multiply the top and bottom of 2/3 by 12. This will give me 24/36 plus 25/36 equals 49/36. That's actually really nice. I was not expecting that. 49/36 on the left. And I say that's really nice because I can actually take the square root of that. Don't forget the plus or minus when we do so. So we'll have plus or minus 7/6 equals x plus 5/6. Then we can subtract the 5/6 from both sides. But actually, let's break this up into 2 things because we'll actually be able to combine terms here. So we have x plus 5/6 equals 7/6, or x plus 5/6 equals negative 7/6. Now we can subtract the 5/6 off of both sides and get x equals 2/6, which reduces to 1/3, or, whoa, screen went crazy. Sorry about that. Subtract 5/6 from both sides of the second equation. We get x equals negative 7/6 minus 5/6 is negative 12/6, which reduces to negative 2. So our x-intercepts are 1/3, 0, and negative 2, 0. All right, that is it for this video.